Okay, Chapter 13 review for test. Number 1, how long? So as I'm reading a question, I'm always going to look for keywords. So how long means I want to find the time. And let me put a paper side by side so we can see it. So how long means I want to find the time. Will it take a light wave to travel a distance of 100 meters? So I know the distance is 100 meters, and I know that light in a vacuum all has the same speed, 3.0 times 10 to the 8 meters per second. Okay? So I know that velocity is distance over time. So time is going to be distance over velocity. So I rearrange the equation to solve for the unknown in terms of unknown. Don't make an algebra mistake on something that has 3 variables. A lot of times you want to do it in your calculator. That's what you have scrap paper for. Okay? So we're going to rearrange this, and so t is going to be x, 100 meters, over 3.0 times 10 to the 8 meters per second. So that answer comes out to be C, 3.33 times 10 to the negative 7. And again, you want to ballpark this answer. So even though this is 100, that's like 1 times 10 to the 2, so like 2 minus 8. You know what I'm saying? You want to still know the rules for exponents so you can ballpark it. You see how a lot of these, the answers are all wrong? See how this is 10 to the 10, 10 to the 8, and 10 to the 7? So you could actually do this one without even doing the calculation, because if you looked at all the wrong answers, you'd be like, oh, those are wrong. Number 2, what is the frequency of a light wave with a wavelength? So they're giving me the wavelength, so that's lambda. So lambda is equal to 6 times 10 to the negative 7. And we know C is 3.0 times 10 to the 8 meters per second. And remember, these are the same equations. So whether I have V is equal to F lambda or C is equal to F lambda, remember C is the speed of light in a vacuum. And then they gave us the wavelength, and it says what is the frequency. So we want to find F. So C is equal to F lambda, and so F is equal to C over lambda. So when I do that, my answer comes out to be D, 5 times 10 to the 14. Number 3, in a vacuum, all electromagnetic waves have the same velocity. Okay? And you might also see this as speed. Remember, speed is the magnitude of velocity. Velocity is just speed in a particular direction. So remember how these are related. So depending upon how a question is phrased, you should realize that. Number 4, the diagram below shows a beam of light entering and leaving a black box. So it shows here waves vibrating in the vertical plane is the dark line, and this is waves vibrating in the horizontal plane. Now, as our pre-lab on Friday, I did this as a demonstration, and what I did was I showed you that polarizing filters block out light in one particular plane. So remember how I actually held the polarizing filters vertically? Then I put the other one on top of it vertically, and light was still able to go through. Then when I turned them perpendicular to one another, we saw it blocked out all light. Okay? So the answer to number 4 is going to be D. Number 5, which waves are not electromagnetic? So electromagnetic waves do not need a medium to travel through, and we already learned that sound waves need a medium to travel through. We learned that in the last chapter. Number 6, which electromagnetic radiation has a wavelength shorter than visible light? So remember, one of the things that you need to know, and you needed to know this for the quizzes, you have to memorize the order of the electromagnetic spectrum. And we know that radio waves have the longest wavelength, and we know that cosmic has the shortest, but a lot of times they just say gamma. So the answer here would be ultraviolet. So this answer here is A. All right, going on the other side, it says the diagram below represents a light ray being reflected from a plane mirror. The angle between the incident ray and the reflected ray is 70 degrees. What is the angle of incidence? Now, first of all, we know that these rays are measured. Our frame of reference in physics is this perpendicular line we call the normal. Now, the angle is right here. So this is the angle of incidence is this, and this is the angle of reflection. Okay? And they tell us this big angle here is 70. Well, this is 35, so this is also 35, because the normal is going to split it in two, and we know the angle of incidence is equal to the angle of reflection, so our answer is B. Number 8. A ray is reflected from a surface as shown in the diagram. Which letter represents the angle of incidence? So remember, incident means where it's coming from, and reflected means where it's going to. Okay? So this is a basic diagram when we first talked about the angle of incidence. So it's just saying which one's the incident ray, which is this angle here, which is angle B. You know, these are the types of questions that even though they're conceptual, this is a type of question that should take you no longer than, what, 5 minutes to do? Okay? Now, number 9, it says the diagram below shows parallel rays of light on a irregular surface. So here's my irregular surface. It looks like water. And it says which phenomena of light is illustrated in the diagram, and this is diffuse reflection, which pretty much is, you saw a very similar diagram when we first introduced the chapter in your notes. So the answer there is D. Number 10. A beam of parallel rays of light is reflected from a plane mirror. After reflection, the rays will be, so if this is a plane mirror, remember that means flat. Okay? So you remember that when they're reflected, they're all going to be parallel with one another, and we also have that diagram in our notes. And if you remember back, again, that visual, because it has a smooth surface. When it's irregular, they're not parallel, but when it's a smooth, flat surface, they're going to be parallel. Okay, number 11. It says, which diagram represents the reflection of an object, O, by a plane mirror, M? So now I have to look at the choices. So O is the object. So the object, here's the top. So pretend that's you, and you're standing in front. This is the mirror, and your head is closer, and your feet are further away. Okay, so what's your reflection going to look like? It's not going to look like this, right? It's not going to look like this. When you're standing, and if your head is closer to the mirror, and you're the object, what's it going to look like? It's going to look like this. Your head's going to be closer, and your feet are going to be further away. Okay, so the answer is C. An object is placed in front of a plane mirror as shown in the diagram at the right. Which diagram below represents the image that has formed? Okay, so the best way that I would look at it is, I would look at, okay, this triangle is not an equilateral triangle. All three sides are not equal, right? So here's the small part. Now, one tip of the small part is here, closest to the mirror, okay? And then you have the other two parts facing away. So what I need to do is I need to look at them and say which one looks like the reflection. A lot of times the best way to do it is to like flip it over. You know what I'm saying? In your mind. So the answer here is going to be B. So when we look at it, this one has the close part here, and then it has this long part further away. Okay? So here, you see here how there's like two parts that are close, so we're going to eliminate that. This one has the close part, but it's flipped the other way. And then this one I'm definitely going to eliminate as well. So the choices really were these, but then I have to look closely and say, okay, so picture yourself, we all look in a mirror every morning. Okay? So that should be something that you should be familiar with. Number 13. The diagram below shows parallel monochromatic incident light rays being reflected from a concave mirror. The mirror fails to produce a sharp focal point as a result of, and this again in our notes, the definition of spherical aberration, where we have an almost similar or identical. So we see that as the parallel lines come in, because of the curvature of the mirror, they don't all meet at a point. Okay. Number 14. So now we have some problems to do here. It says concave. Is this important, concave? Absolutely. And why is it important? Because if we're just solving this problem mathematically, remember, whenever we have a mirror, we have the same frame of reference. For concave, when I draw my principal axis, my center of curvature, and that means if I was going to make a circle, is going to be positive, and my focal point is going to be positive. When I have the other type, which is convex, with convex, C and F are negative. So that makes a huge difference when doing calculations. So let's look at number 14. So number 14 says it's concave, and it says it has a radius of curvature of 60. So the radius of curvature is actually what? C. And I know that F is equal to C divided by 2. So it's 0.6 divided by 2 is going to be 0.3. So that's in my given. Then it says when an object is placed, so that's the distance of the object, DO, that's equal to 0.4. What is the image distance? So I want to find DI. So our basic equation for doing these problems is 1 over F is equal to 1 over DI plus 1 over DO. Now, I do not recommend plugging numbers in your calculator. Now, even though your calculator has that 1 over X button, what happens is people make mistakes. So I've already showed you many times how to rearrange this equation to solve for the unknown in terms of the known. So when we do that, DI is equal to DOF divided by DO minus F. So that's equal to 0.4 times 0.3, 0.4 minus 0.3. So DI comes out to be 1.2 meters. And then my answer here would be D. Number 15 says a person is standing in front of a diverging, which is a convex, because the rays of light spread apart, which means diverge. What type of image? And when we were talking about convex, I told you that convex images are always going to be erect, virtual, and smaller. And that's it. That's a review.